Welcome to the next session of subject engineering maths. We were in the middle of chapter 7 numerical methods. Now in this session we discuss classroom workbook. So let us start the session with question number 10. The root of the equation x into e power x equal to 1 between 0 and 1, that is open interval between 0 and 1, obtained by using two iterations of bisection method is. So that means we need to apply intermediate value theorem two times over this interval, open interval 0, 1, so that you will get x1 as well as x2. So x2 is required for us. Now let us solve this. Actually, you can take this function as x into e power x minus 1 equal to 0. Let us take p of x equal to x into e power x minus 1. Now this is a continuous function. E power x is continuous, x is continuous, product is continuous, constant function is continuous, difference of two continuous functions is again a continuous function. So this is continuous in closed interval 0, 1. Now let us calculate p of 0. P of 0 is minus 1, it is negative. P of 1 is e minus 1, this is greater than 0 because the value of e is 2.71. Therefore, by intermediate value theorem, by IV theorem, root lies in open interval 0, 1. So therefore, let us write this interval 0, 1. Now here the value of x1 at this place is 0 plus 1 by 2, midpoint of this. So we were applying bisection method, x1 equal to 1 by 2. Therefore, the value of root in the first iteration is 0 plus 1 by 2, this is 1 by 2. Since they mentioned two iterations, I need to apply IV theorem once again. So divide this interval into two subintervals at its midpoint. Open interval 0, 1 by 2, open interval 1 by 2, 1. Now I need to decide whether root belongs to this interval or this interval according to the sign of this function at the endpoints of interval, right? Now let us calculate this p of 1 by 2. So this is half into e power 1 by 2 minus 1. So this is half into, this is p of 1 by 2. This is 1.64 minus 1. So therefore this is 1.64 divided by 2. Divided by 2. This gives me 0.82 minus 1. So this is less than 0. Now p of 0 is less than 0, even p of 1 by 2 is less than 0. So function takes same signs at these endpoints. Root doesn't belong to this. That means p of 1 by 2 less than 0, comma p of 1 greater than 0. Therefore, root belongs to second subinterval, that is 1 by 2, 1. Therefore, root lies in open interval 1 by 2, 1. Therefore, the value of root in the second iteration is midpoint of this interval, 1 by 2 plus 1 divided by 2. This is 1.5 divided by 2. So this is 0.75. So option C is right answer. Note these points. Next we discuss question number 12. Sorry, question number 11. Question number 11. If a cubic polynomial f of x in x has roots at x equal to 1, x equal to 2 and x equal to 3, then which of the following must be true? See, in every option f of 0, f of 4 values are evaluated, right? So therefore it is given as it is a cubic polynomial in x. What is my cubic polynomial? F of x. Cubic means third degree polynomial. Roots are 1, 2, 3. Therefore this f of x can be written as f of x minus 1 into x minus 2 into x minus 3. As every option required f of 0, f of 4, let us evaluate f of 0, f of 4. So f of 0 equal to minus 6 less than 0. F of 4 equal to 4 minus 1, 3 into 2 into 1, it is 6 greater than 0. Now f of 0 less than 0, f of 4 greater than 0. So therefore from options it is clear that f of 0 into f of 4 is less than 0. So option D is right answer. Now let us discuss question number 12. If f of x is a continuous function which does not have a root in closed interval a comma b, then which of the following must be true? Which of the following must be true? So in the first option it is given as f of a into f of b equal to 0. It is given that this equation, f of x equal to 0 has no root in this interval. Whenever this happens, implies either f of a equal to 0 or f of b equal to 0. If this happens, a is a root. If this happens, b is a root. But it is given that this has no root in closed interval a comma b. A and b are included in this interval. It is given as this is a continuous function which has no root in this interval. So option A should not be true, because when option A is true, either A or B must be roots. But that should not be true. So therefore A must be wrong answer. Now what is B option? This is f of A by f of B less than or equal to 0. So when ratio will be 0? Ratio will be 0 whenever f of A equal to 0. Suppose if f of A equal to 0, if f of a equal to 0 implies a is a root. So that should not be happened, because it has no root in this interval and a is a member of this interval. Suppose if f of a by f of b less than 0, when ratio becomes negative quantity, ratio becomes negative when one is positive, another is negative. That implies f of a into f of b is less than 0. Now this is a continuous function and f of a into f of b less than 0. Therefore, by intermediate value theorem, the function has at least one root in this interval. But it is given as it has no root in this interval. Therefore, this should not be true. Therefore, option B also wrong option. Option C. This is f of a into f of b less than 0. So even when you take this, you will get roots inside this interval. So wrong answer. Therefore, D must be right answer. So basically, this question purely depends on application of intermediate value theorem, right? So option D is right answer. Now next we move to question number 13. A real root of the equation x cube minus 2x minus 5 equal to 0 lies between x equal to 2 and x equal to 3. It is given as a real root of this equation lies between x equal to 2 and x equal to 3. The location of the root obtained after second iteration using Regular-Falsy method is. So therefore we need to apply Regular-Falsy method twice. That means we need to apply indirectly intermediate value theorem 2 times over this interval 2, 3. Let us see here f of x equal to, for example, x cube minus 2x minus 5. It is a continuous function between closed interval 2 comma 3. Here interval is 2 comma 3. Now f of 2 is, this is 8 minus 4 minus 5. So this is minus 1. It is less than 0. F of 3 is 3 cube 27 minus 6 minus 5. This is 11. So therefore this is 16 greater than 0. So function takes opposite signs at the endpoints. Therefore root lies between 2 comma 3 or in the interval 2 comma 3. Therefore the value of x1 by regular falsity method is 2 times f of 3 minus 3 times f of 2 divided by f of 3 minus f of 2. So this is 2 into f of 3 is 16 minus 3 into f of 2 is minus 1 divided by f of 3 minus f of 2. 16 minus of minus 1. So this is 35 divided by 17. Now let us simplify this. So it is 35 divided by 17. So it is 2.058. 2.058. So let us divide this interval. So interval is 2 comma 3. So root may belong to first subinterval, that is 2 comma 2.058 or open interval 2.0 comma 58 comma 3. Therefore root may belong to either left subinterval or right subinterval. That depends on sign of the function at the endpoints. So let us calculate this f of x1. So this is f of 2.058. So this is 2.058 whole cube minus 2 into 2.058 minus 5. So this value is required. Let us evaluate this. 2.058 into 2.058 into 2.058. So therefore this expression is 8.716 minus 2.058 into 2 equal to this. So this is total expression is minus 9.116. So therefore this is for 9.116 minus 8.716. So therefore this is minus 0.4. Let us cross check it. 2.058 whole cube, 2.058 into 2.058 into 2.058. This gives me 8.716, right? So 2.058 into 2 equal to this. So plus 5. So you will get 9.116. 9.116 minus 8.716. This gives me minus 0.4. So this is less than 0. Therefore, in this case, f of 2 is negative and this is negative. So root belongs to this interval. So root belongs to, or root lies in open interval 2.058 comma 3. Therefore, x2 equal to 2.058 into f of 3 minus 3 into f of 2.058 divided by f of 3 minus f of 2.058. Now let us evaluate this x2 expression. So this is 2.058 into f of 3 is 16 minus 3 times f of 2.058, that is minus 0.4 divided by 16 minus of minus 0.4. Now let us simplify this. 2.058 times 16 equal to 32.92 plus 3 into 1.4. This gives me 4.2 divided by this is 16.4. So therefore this is 4.2 plus 4.2 plus 32.92. This is 37.12 divided by 16.4. So divided by 16.4. So this gives me 2.26. Of course, it is not there in options. So let us cross check it. The value here it is. The function is x cube minus 2x minus 5. So f of 2 is minus 1. F of 3 is this. Okay, this expression is, this is f of 3 minus f of 2.0.058. So this is minus 0.4. So therefore this gives me so it is giving wrong evaluation. Let's cross check it. F of 2.058. This expression is 2.058 whole cube minus this. So let me cross check it, this value. Two 2.058 into 2.058 2.058 times 2.058 for this into 2.058. This is 8.716. Two 2.058 into 2, what is this? Minus 5. So it gives me this minus, add 5, you will get this minus 8.716. It gives me 0.4. So it is negative value. So x2 becomes 2.58 into f of 3, 16, minus 3 into this value, 2.58 into f of 3 minus this divided by f of 3 minus this. So f of 3 is 16 only. This is like this. So therefore let's check it this. So total value becomes, this is 16.4. So this is 32.92 plus 4.2. This gives me 37.12 divided by 16.4. So this is 2.26. But when you go through options, we do not have 2.26. Now let's solve this problem in next session. Let's move to next question. So let us move to question number 14. The equation x square minus 4x plus 4 equal to 0 is to be solved numerically starting with initial guess x not equal to 3. The NOR method is applied once to get a new estimate, and then secant method is applied using initial guess and this new estimate. So the estimated value after the estimated value of the root after application of secant method is. So therefore we need to apply two methods. One is Newton-Raphson method followed by secant method. X naught is given as 3. Apply Newton-Raphson method, we get x1. So based on x naught and x1, calculate x2 using secant method, right? Now let us see. Actually here the function f of x is x square minus 4x plus 4. So therefore this is x minus 2 whole square. Now this is f of x naught equal to f of 3. So this is 1. F dash of x equal to 2 into x minus 2. So f dash of x naught equal to this is 2. So 2 into 3 minus 2, you will get 2. Therefore, the value of x1 using Newton-Raphson method is x naught minus f of x naught divided by f dash of x naught. X naught is 3. This is 1 by 2. So therefore, this value gives me 2.5. Therefore, we got x1 value. Now x2 value is x1 minus x naught divided by f of x1 minus f of x naught into this is f of x naught. So f of x1. So therefore x1 is given as 2.5. This is given as like this. So let us calculate f of x1. So this value gives me f of 2.5. So therefore this is 2.5 minus 2 whole square. So this is 0.5 whole square, 1 by 4, this is 0.25. Therefore the value of x2 is, x1 value is 2.5 minus 2.5 minus x1 3 divided by f of 2.5 minus f of 3, or this one, x naught is 3 into f of 2.5. So here this is 2.5 minus, this is minus 0.5 divided by f of 2.5 is 0.25 minus f of 3 is given as 1 into this f of 2.25, 0.25. So therefore this is 2.5, this is minus 0.25 divided by minus 0.75 into 0.25. Therefore this expression is 2.5 plus 0.5 into 0.25. This I can write it as 0.25 into 3. So this and this expression gives cancelled. So we get this as 2.5 plus 0.5 by 3. Now let us evaluate this. So therefore this expression is 2.5 divided by 3. This gives me 0.83 plus 2.5. So therefore approximately this value is 3.33. At first we got 2.5, this value. Now let us cross check it, this value. This is 2.5. Of course this is minus minus plus, this gives me minus value. It is minus, it is minus. Now therefore this is subtract 0.5 by 3. This is 0.5 by 3 equal to 0.16 minus 2.5. So therefore this value is 2.33. Therefore in the first iteration we got 2.5. Initial approximation is 3. In the next approximation we got 2.5. We applied Newton-Raphson method once, we got 2.5. After that we have applied secant method using x1 as well as initial approximation. We got 2.33. So this is the right answer. Note this. Now let us discuss question number 15. Consider a differential equation dy by dx minus y equal to x with initial condition y of 0 equal to 0. Using Euler's method with a step size of 0.1, comma, the value of y of 0.3 is, this is the first order first degree differential equation, dy by dx minus y equal to x. So what is the initial condition? Y of 0 equal to 0. Step size means h. It is given as 0.1. So we need to find y of 0.3. Y of 0.3 is required. Dy by dx minus y equal to x. Y of 0 is 0. Step size is 0.1. We need to find y of 0.3. Now let us see. This differential equation can be manipulated like this: dy by dx equal to x plus y. So this entire function x plus y, we can treat it as function in two variables, x comma y. Initial condition, y of 0 equal to 0. So this is x naught value 0 and y naught value is 0. Step size is given as 0.1. We need to find y of 0.3. Y of 0.3. Now this 0.3 is nothing but y of 3h. So y of 3h means you need to find y3 value, because y of 0.3, this 0.3 can be expressed as positive integral multiple of h like this. Y of 3h means you need to find y3. That means value of y in third iteration. To get value of y in third iteration, you require value in the previous iteration, that is y2. To get y2, you need to get the value of y in the first iteration, that is y1. Therefore, at first we will calculate y1 value. Y1 is given by using Euler's method, that is Runge-Kutta method of order 1. So y naught plus h into f of x naught comma y naught. So y naught is 0 plus 0.1 into f of x comma y is this. So f of x naught y naught is x naught plus y naught. So this is 0.1 into x naught is 0, y naught is 0. So this becomes 0. So y1 is 0. Next y2 becomes y1 plus h into f of x1 comma y1. Of course, what is x1? This is x naught plus h. It is 0.1. So therefore y1 is 0 plus 0.1 into f of x1 y1 is x1 plus y1. So this is 0.1 into x1 is 0.1 plus y1 is 0. So therefore 0.1 into 0.1, this is 0.01. So y2 value we got as 0.01. Next, let us find y3, the value of y in third iteration. This is given by y2 plus h into f of x2 comma y2. Now what is x2 value? X2 value is x1 plus h. Already x1 is 0.1, h is 0.1. So this becomes 0.2. So y2 value is 0.01 plus 0.1 into f of x2 comma y2 is x2 plus y2. So 0.01 plus 0.1 into this x2 value is 0.2 plus y2 value is 0.01. So therefore this is 0.01 plus 0.1 into this is 0.21. So 0.01 plus 0.021. This is 0.031. This is the value of y in third iteration. Therefore, it is option number B. The differential equation dy by dx equal to 0.25 into y square. 0.25 into y square is to be solved using Euler's method with a boundary condition y equal to 1 at x equal to 0. That is 1 is nothing but value of y naught and 0 is x naught value. Step size is 1, that is h value 1. What would be the value of y at x equal to 1? That is y of 1 is required. Now this is same as previous model. This is f of x comma y. So here f of x comma y is 0.25 into y square. H value is 1. We need to find y of 1. This 1 we can write it as 1 into h. So x can be expressed as positive integral multiple of h. That means you need to find y1 value. So here y1 value by using Euler's method, that is RK method of order 1 is y naught plus h into f of x naught comma y naught. Here y naught value is 1. 1 plus this is 1 into this is 0.25 into y naught square. So therefore this is 1 plus 0.25. Therefore the value is 1.25. So it is y value is 1 at x equal to 0. Y naught plus h into f of x naught y naught. F of x naught y naught is 0.5 into y naught square. Y naught is 1. That is very clear. So 1 plus 0.25, it is 1.25. Now let us move to question number 17. While solving numerically, the equation dy by dx plus 2xy square equal to 0 using RK method of order 1 with a boundary condition y of 0 equal to 1 with a step size 0.2, the value of y after first step. That means we need to find y1 value. So this is my differential equation. RK method of order 2. Actually here f of x comma y is minus 2xy square. So take 2xy square to the right side, it becomes f of xy is minus 2xy square. So here x naught value is 0, y naught value is 1, step size is 0.2. They were asking y1 value. So therefore, if you want to apply RK method of order 2, you need to find two parameters. They are K1 and K2. They are K1 and K2. Therefore, for K1, the formula is h into f of x naught y naught. So h into f of x naught y naught is minus 2x naught y naught square. But x naught is 0, so this becomes 0. K2 value becomes h into f of x naught plus h by 2 comma y naught plus k1 by 2. So therefore h value is 0.2, f of x naught is 0, h value is 0.2. So f of 0.1, y naught value is 1, 1. This is k value. So therefore this is 0.2 into minus 2 into 0.1 into 1 square. So therefore this is 0.2 in minus 0.2 into this. So this is minus 0.04. So y1 equal to y0 plus delta y. But what is delta y? As per RK method of order 2, it is K2. So therefore y1 equal to y0 value is 1. K2 value is minus 0.04. Therefore this becomes 0.96. Therefore the value of y after first step using RK method of order 2 is 0.96. Therefore it is option number D. The session is over. Thank you so much. We continue class to workbook in the next session.